Hello everyone. Today we are going to introduce the first set of models, static models. As we emphasized over and over again, the question determines the method. The research question we try to address in this part is to explain business cycles in the labor market, which is featured with static decisions. That is why we use static models. In general, short-run business cycles are costly because it can lead to economic instability and political instability. For example, the Great Depression in 1930s partly contributed to the Second World War. For individuals, you don't want to graduate in the year of recession because it would be difficult to find jobs. According to empirical research, those who graduate in recession years tend to earn significantly less in their lifetime. Students who graduated in the decade following the global financial crisis in 2008 are called the lost generation because they were greatly disadvantaged in the labor market. Therefore, our journey of macroeconomic theory starts with business cycles in the labor market, given its importance. The first question we try to address is to explain business cycles or stylized facts in the labor market. This is called positive analysis because the purpose of this is to describe how the economy works from a positivist point of view. Furthermore, we hope we can also work out how to manage business cycles if we are able to do so. This additional ambition is prescriptive, so it belongs to the so-called normative analysis. The two analyses, positive analysis and normative analysis, are usually entangled together in economics. You can't manage the economy without understanding the economy first, and your understanding of the economy is almost always affected by your value and judgment. To answer the positive and normative questions on business cycles, we take a gradualism approach in developing our modeling method. We will first introduce static models and then go dynamic. We will first cover real models and then add monetary elements. We will first focus on closed economies and then extend to open economy models. Therefore, we start with the simplest model, a static, real, closed economy model, to explain business cycles in the labor market. We adopt static models to explain business cycles in the labor market because decisions in the labor market are usually static, which means that decisions made today do not affect future periods. The question is to explain stylized facts of business cycles in the labor market. The first one is the extensive margin, which is the decision on whether or not to work. It is called extensive margin because it determines how extensively people work. The second one is the intensive margin, which is the decision on how much to work if they work. It is called intensive margin because it determines how intensively people work. In the data, we find the following stylized facts. Volatility of the extensive margin is greater than that of the intensive margin. The extensive margin is procyclical, while the intensive margin is acyclical. The effect of shocks to the extensive margin can persist for about 6 to 8 years. To match these stylized facts, we will adopt the new classical method and develop a simple static model with micro foundation. The static question in the labor market determines the static model of the labor market. Recall that micro foundation means deriving macroeconomic relationships from microeconomic principles such as optimization and equilibrium. Therefore, the micro foundation method determines the microeconomic techniques which you have learned in your A-level maths and other modules. Specifically, you must know the following 3 quantitative techniques to understand this module. The first technique is to obtain optimization using differentiation. If you do not know what is taking derivatives or the chain rule, then you need to go through the maths revision I provided on the website. In fact, as an economic graduate, optimization is the most fundamental technique you should have learned. The second technique is to obtain equilibrium using equation solving techniques. In your maths modules, it usually asks you to solve a 2-variable or 3-variable simultaneous equation system. In our module, it is similar but more tedious because we may have up to 7 variables in the simultaneous equations to be solved. However, the logic behind is exactly the same. Substitute the unknown variables out one by one until you have only one unknown left. The third technique is comparative statics analysis. You should have learned that in year 1 micro, or you will learn that in year 2 micro. It is basically to analyze the effect of a change in exogenous variables on the endogenous variable. For example, when there is a rise in productivity, there will be a rise in output and wage. In your first year, you can use economic intuition to shift the curves and obtain the qualitative conclusion. But in this module, you will be able to quantitatively solve how much the shift is. This is a big map of all the models we are going to cover in this module. I will repeatedly show you where we are throughout the journey. We will begin with a simplified static model to model business cycles of the labor market. Recall that these models are essentially methods which are determined by the questions at hand. That is why we have different horses for different courses. Just want you to understand that we develop so many models for a reason, not just for fun. Reflected on our graphical conceptual framework, we focus on one of the 2 input markets, the labor market, and its fluctuations along business cycles. Again, note that in all models, we always have an output market, because the output is the benchmark to define business cycles. There are 3 economic agents in the model: the consumer, the firm, and the government. All 3 are optimizers for their own interest. We have 3 learning objectives today. First, you should understand how to quantitatively model the representative consumer's utility maximization problem. Second, you should understand how to quantitatively model the representative firm's profit maximization problem. Third, you should be able to derive the intratemporal conditions of the 2 agents in terms of words, maths, as well as graphs. I assume you know the basics of microeconomics and maths, such as optimization and taking derivatives. If you feel difficulty in keeping up, please review your maths because you will need these techniques all the time in this module. The maths revision slides available on the website provide a direct guidance in a macroeconomic context, while the short course in quants provide a more thorough and systematic revision. First, let's look at the supply side of the market, the representative consumer. We will separately model its objective and its constraint before combining the 2 building blocks in the optimization. The supply side of the labor market is, of course, workers. In fact, they are also consumers in the output market. The same people, but different roles. We will just call them consumers for simplicity. Different from microeconomic perspective of the labor market, aggregation is needed in macroeconomic models. It is not possible to model everyone separately and then aggregate them up. Instead, the mainstream macroeconomic models adopt a so-called representative consumer assumption. This representative consumer is the average consumer in the per capita sense. We treat this representative consumer as the rational decision maker in the labor market. Note that this representative consumer actually does not exist in reality. You cannot find a counterpart individual behaving like this representative consumer. It is just a personalized average quantity. To provide micro-foundation for macroeconomic models, we describe the representative consumer's behavior as utility maximization subject to constraints. One is the budget constraints, and the other is the time constraint. This is exactly the same as the consumer theory you have learned in microeconomic theory. The micro-foundation methodology was developed in 1980s by the new classical school to respond to the Lucas critique. To know more about the Lucas critique, you can go to lecture 0.1 and read the slides on the brief history of macroeconomic models. Long story short, the old-fashioned macroeconomic models before 1980s were ad hoc, and the relationships among macroeconomic variables are criticized by Lucas to be statistic rather than structural. Lucas argues that these statistical relationships are not stable and can change if policies change. To solve this problem, Prescott and Kitland developed the first generation of micro-founded models such that all the relationships derived from micro-foundation are structural and immune to the Lucas critique. Since then, micro-founded models becomes the mainstream modeling approach in macroeconomics. However, micro-foundation itself receives many criticisms too. It assumes the representative consumer is rational and maximizes utility, but we know that many people are irrational. As a response, the new classical modelers argue that there are stupid people with irrationality, but there are super smart people with super rationality as well. So according to the law of large numbers, the average behavior must converge to rationality. Another criticism is that the representative consumer assumes away the difference between the poor and the rich, so it cannot discuss inequality issues. The new classical modelers find a way to deal with this by introducing heterogeneous agent models. Compared to the two technical criticisms, there are two fundamental criticisms to the representative agent assumption. The first is the fallacy of composition, which argues that the whole may not have what parts have. I still remember the nursery rhyme my son used to sing. It goes like, "Do you like ice cream? Yes. Do you like broccoli? Yes. Do you like broccoli ice cream? Yuck." And the same logic goes to the representative agent assumption. Even if each individual is rational, the aggregate may be irrational. Think about the stock market. All investors may be super smart, but there are always bubbles in the stock market. It is not because people are stupid, but because every smart person tries to ride on the bubble to earn a profit. It is ironic, but the reality is that the sum of a bunch of smart people result in aggregate stupidity. Another related fundamental criticism of the representative consumer assumption is the fallacy of division. It means parts may not have what the whole has. It is the reverse of the fallacy of composition. It is like you may love your boyfriend, but it doesn't mean you love everything about him, like being a douchebag sometimes. For the representative consumer assumption, you assume rationality as a whole, but it doesn't imply that every individual maximizes their utility. Therefore, the welfare implications of the model can be extremely misleading. Despite the fundamental flaws of the representative consumer assumption, it is still the most popular approach adopted in macroeconomics. We are going to introduce how microfoundation is built by optimization problem of the representative consumer, but you should be aware that this mainstream methodology is not perfect. The representative consumer's optimization problem has two building blocks, as you have learned in microeconomics. The first is its preferences, which describe the objective of the consumer. The second is its constraints, which describe the feasible sets within which the consumer maximizes its objective. For a macroeconomic model for the labor market, we usually assume that the consumer cares about two things: consumption C and leisure L. Recall that preferences can be modeled in two mathematical forms. The utility function determines U by C and L. A popular utility function is Cobb-Douglas, look like this. The powers alpha and 1 minus alpha represent the utility shares of C and L. In the graph, the utility function is a 3D surface because it has two independent variables, C and L, and one dependent variable, U. For any combination of C and L, there will be a point U on the surface. An alternative but equivalent form is indifference curve. If we cut the 3D surface of the utility function at a given level U, then we will have a horizontal contour of the surface. Project this contour onto the LC coordinates. We will have a convex curve. This convex curve is the indifference curve. As you can see, a higher utility level results in a higher indifference curve. In fact, these should be taught in your microeconomic theory, but I quickly run through this knowledge to facilitate your understanding in macroeconomic context. Based on the 3D utility function and the 2D indifference curve, there are some important properties of preferences. The first-order property of preferences can be defined by the first-order derivative of the utility function and indifference curve. If you define it using the utility function, then it is called marginal utility. If you define it using the indifference curve, then it is called marginal rate of substitution. Either way, the first-order property of preferences is that the more you consume the same good, the happier you will be. In graph, it means a positively sloped 3D surface, and in maths, it means a positive first derivative. The second-order property of preferences is that it obeys the diminishing law. In words, it means the more you consume the same good, the less happier you will be. Although you are happier, but the increment become less and less. In graph, it means a concave 3D surface and a negatively sloped 2D indifference curve. In maths, it means a negative second derivative. The law of diminishing marginal utility or diminishing marginal rate of substitution is a defining feature of all new classical models. We will use this property frequently in our future analysis, so please do keep this in your mind. One interesting implication of the diminishing law is that the cross derivative is positive. That is to say, if you take derivative with respect to consumption first, and then take derivative with respect to leisure, then this second derivative is positive. It is like the more you eat bread, the more you want to eat butter. It is because there is a complementarity between different goods. Average is preferred to extreme. So there is a tip for boys. If you want your girlfriend to love you more, ask them to make more male friends. Otherwise, they will be fed up with you one day due to the diminishing law. Now let's turn to the second building block of the optimization problem of the consumer. In your microeconomic theory, the consumer's problem usually only has one constraint, that is the budget constraint. That is how you allocate your income or goods endowment among different goods. In the macroeconomic models with labor market, this budget constraint is the same, but the income is now endogenous because it depends on how much you work. The total income, as we described in the coconut example in lecture 0.2, is equal to labor income wage, W, multiplied by the number of hours you worked, NS, or labor supply, plus profit per capita pi, minus tax per capita T. The total expenditure in this simple example is just consumption C. It is a static model, so there's no investment or savings. The total income should be equal to the total expenditure. On the other hand, the consumer also faces a time constraint. The consumer needs to allocate its time endowment between work and leisure, because our question is the labor market. Let's denote the time endowment by H, which is 24 hours a day, or 7 days a week, or 365 days a year. It is the same for everyone. No one has 25 hours a day. The time constraint is simple. H equals to leisure L plus labor NS. It is worth pointing out that the wage here is real wage, because we start with the real economy. There's no money. The numeraire in this model is the output, so everything is denominated by units of output. For example, the price of consumption is 1 because consumption is part of output. They have exactly the same price. The price of labor is real wage, which is denominated by units of output. The two constraints, the budget constraint and the time constraint, can be combined into one constraint. As you can see, there is one common variable in the two constraints, the labor supply NS. Therefore, it is straightforward to substitute out NS in one equation by the other. I will leave this job to you to finish it. After substituting out NS, the combined constraint can be written in this way. You may ask, why do we write it in this particular fashion? Well, it is because we focus on the two endogenous variables, C and L, which we try to explain. C is actually a linear function of L. Compare it with the standard form of a linear equation. C is the dependent variable y, L is the independent variable x, minus w is the slope a, and the intercept is the terms inside the bracket. In fact, C and L are both endogenous variables, but we have to pick one as the vertical axis variable and the other as the horizontal axis variable. By convention, C is the vertical, but in principle you can use L on the vertical if you really want to. We can draw the combined constraint in the CL coordinates. We know that time endowment H is exogenously given, so the maximum of leisure cannot exceed H. So there are two possibilities. If profit pi is less than tax T, then horizontal intercept H plus pi minus T over W will be less than H. The constraint is a straight line. However, if pi is more than T, then the intercept is higher than H. The constraint is a kinked line. The area below the constraint is the feasible set. If wage is lower, the slope of the constraint is flatter, and the feasible set will become smaller. Now that we have discussed the objective and the constraint of the optimization problem of the consumer, we can combine the two building blocks and work out the optimal choice. If the wage level is high, then the optimal choice lies in the interior. The consumer will allocate a proportion of time in leisure and the rest in labor supply, NS. As the wage level drops, the constraint line becomes flatter from I2 to I1, and the optimal choice shifts from H to F. You are going to learn how to decompose the total shift into a substitution effect and an income effect in microeconomic theory. In this case, the income effect is from H to O, and the substitution effect is from O to F. The two effects perfectly cancel out their influences on labor or leisure time, but consumption drops from C2 to C1. This is called the intensive margin because the optimal choice determines how intensive the consumer works. As wage keeps dropping, the slope keeps flattening out. At some point, the optimal choice will be stuck at the kinked corner B. That is, the consumer will choose not to work at all because the wage is too low to motivate them. Beyond that point, the change of wage is no longer relevant. The threshold level of wage describes the extensive margin because it determines whether the consumer works or not. In the previous slide, we used the graphical way to show the intuition behind optimization. In this module, you are also required to solve the model mathematically. Note that these two processes are equivalent. Now let's formulate the optimization problem of the representative consumer as an objective function, the utility function, subject to the combined constraint. To be general, we keep the utility function in an implicit form, U of C and L, which means utility simply depends on consumption C and leisure L without an explicit specification. In the tutorial, we will use an explicit function form of Cobb-Douglas so that you can obtain an explicit solution. In the quants module in your first year, you have learned optimization with constraints. There are two methods. The first one is the Lagrangian method, and the second one is the substitution method. In this module, we will always use substitution method, but the Lagrangian method can arrive at the same answer. You can try if you are interested. The logic of the substitution method is to transform an optimization problem with constraint into an optimization problem without constraint. There are three steps. Step 1 is to substitute all constraints into the objective function. Every constraint can be used to substitute out one endogenous variable. In our case, we can substitute out C. Of course, if you want, you can substitute any variable like leisure, but it won't make any difference. The second step is differentiation of the new objective function with respect to the endogenous variables and set the derivative to 0. Why do we do that? It is because the derivative is the slope of the objective function. When the slope is equal to 0, we are at the top of the curve. Because we are maximizing the utility, so the slope must be equal to 0 at the maximum. This condition is also called first-order condition because it involves first derivatives. It is also called marginal condition because it involves marginal utility. The third step is solution of the marginal condition. Keep in mind that you may have corner solution where the solved leisure is greater than h. In this case, you must discuss the extensive margin rather than the intensive margin. Now let's apply the substitution method to the consumer's problem. Step 1, substitution. We substitute C of the constraint into the objective function, so there is only one endogenous variable L left in the objective function. Step 2, differentiation. Note that our objective function is a multivariate function depending on two components. The first component is C, which depends on leisure L, and the second component is leisure L itself. So if leisure L changes, there are two paths to affect the utility. The first is through the effect on the first component C, and the second is through the effect on the second component L. Therefore, the differentiation involves the multivariate chain rule. The details of this is taught in your A-level and first year. If you forget, please go to the maths revision slides for more details. This technique is very important for understanding the lecture and the tutorial. The first term is the definition of the marginal utility of consumption. The second term is the derivative of the linear function of c equals to minus w. And the third term is the definition of marginal utility of leisure. If we rearrange it a little bit, we have obtained the marginal condition. The left-hand side is the marginal cost of leisure, and the right-hand side is the marginal rate of substitution between leisure and consumption. This marginal condition is also called the intratemporal condition because it describes the optimality of a static decision within a period. It is intratemporal because the decision only affects variables within one period. The third step is to solve for the optimal leisure based on the intratemporal condition. Note that on this slide we cannot solve it explicitly because the function form is implicit to keep things general. In the tutorial, we will specify an explicit function form of the utility so that you can obtain an explicit solution to leisure as well as labor. In the solution, we express each endogenous variable like leisure, labor, and consumption only in terms of exogenous variables and parameters like W, H, pi, T, and so on. If there are two endogenous variables in your solution, then this is not yet solved. In the solution, only exogenous variables and parameters are used to express each endogenous variable. Wage is treated exogenous to individual consumer because we assume a competitive market and consumers are price takers. And of course, you should be aware of the corner solution and extensive margin. The solution is essentially a function of labor in terms of wage and other things. It is actually the mathematical equation underlying the labor supply curve. There are always two sides of a market. We have just modeled the supply side of the labor market. Now let's turn to the demand side of the labor market. Similarly, we will adopt the new classical micro foundation to assume a representative firm to describe the supply side of the labor market. To be consistent with the representative consumer, we are using the total number of consumers, NC, as the denominator to define the representative firm, not the total number of firms, NF. In this way, the output produced by the representative firm is the output per capita, not output per firm. And the profit is profit per capita, not per firm. Also similar to the consumer's problem, the firm's problem has two building blocks, the objective and the constraint. The objective of the representative firm is the profit, which is defined as the total revenue minus total cost. Since output is the numeraire, the price is 1. So the total revenue is just equal to 1 multiplied by the output, y. The total cost is the labor cost, wage W multiplied by labor demand, ND. In your microeconomic theory, you will learn that the firm's problem can be modeled as a cost minimization problem, which is a part of profit maximization problem. Cost minimization is necessary but not sufficient condition for profit maximization. So we will use a one-stop setup of profit maximization to model the firm's behavior instead of a cost minimization. The constraint of the firm is the technology, which can be mathematically modeled in two forms, just like preferences. The 3D graph is the production function, which is the counterpart of utility function in the consumer's problem. Y is output, which is a function of two inputs, capital K and labor N. In our model, capital is fixed because we only focus on the labor market. Z here is the total factor productivity, or TFP, or the solo residual. If Z rises, the production function will shift up. The 2D graph is the isoquant, which is the horizontal contour of the 3D production function. It is the counterpart of the indifference curve in the consumer's problem. As you can see, the firm's technology also has first-order property of positive marginal products and second-order property of diminishing law. In addition, it has a multivariate property, returns to scale. Note that the first and second-order properties state that if only one input rises, the output will rise, but the rise diminishes. They are essentially univariate properties because it discusses only one input. In contrast, return to scales discusses if both inputs rises. The output will rise more than or less than proportion. In new classical models, we usually use the Cobb-Douglas production function, which is constant returns to scale. Now we are ready to combine the two building blocks of the firm's optimization problem. The objective function is a positively sloped line because the profit function can be written as y equals to w multiplied by n plus pi. It is written in the function of y in terms of n because the production function is also a function of y in terms of n. The constraint is the production function with fixed capital, which is a concave curve. The maximum profit occurs when the two are tangent. The optimal condition is therefore marginal product of labor equals to wage, the slope of the profit function. Behind the graph is mathematics. It is the same as the consumer's problem again. It can be written as the profit maximization subject to production function. We will use the substitution method to derive this. The first step is substitution. It is straightforward to substitute out y in the objective function by the constraint. If you really want to be different, you can also substitute the other endogenous variables, labor demand and d out, but it is more tedious. The second step is differentiation. After substitution, we only have one endogenous variable left, that is labor demand, n. Apply univariate chain rule, and we will have the marginal condition for the firm. Marginal product of labor equals to wage. That is the firm's part of the intratemporal condition because this decision only affects variables within one period. The third step is to solve the optimal labor demand in terms of exogenous variables like wage, W, productivity, Z, and capital K. Again, on the slide, you cannot solve it explicitly, but in the tutorial, you will be given an explicit production function and solve the model explicitly. Note that the solution is essentially a function of labor demand in terms of wage. It is the mathematical equation underlying the labor demand curve you have learned in A-level and first year. To summarize, we adopt the mainstream method of microfoundation to model the labor market by a representative consumer and a representative firm. This method is not flawless, but it is the most popular way. The two agents are rational, so they maximize their objective functions subject to constraints. You should be able to use words, graphs, as well as mathematics to describe the optimization processes. Please do take a look at maths revision on the website. If you are not confident in your maths, please also feel free to go through the short course in quants more systematically. Do not panic if you cannot digest everything right away. Learning microeconomic theory will help you along with macroeconomic theory. And we will repeat this technique over and over again. Try to do the self-tests and the tutorial questions. Have fun!